Today I will try to show you how to configure static routes between two different networks. For our demonstration lab, I use our common example as seen in the previous videos. I have the finance department, which it has terminals spread around the ground and first floor. I have the sales department with terminals on the ground on the first floor as well. I have a switch per floor, one switch for the first floor, another switch for the ground floor, and then I have a control switch that can be based either on the ground floor or the first floor, or physically can actually be based wherever you want. Connected to my control switch, I have the distribution layer router. Connected to my distribution layer router, I have a new core layer router that is actually giving us access to a remote network represented by PC4 in this scenario. That is the network 192.168.3.0. The finance and sales department actually use the common IPs that I've shown before. The network is 192.168.1.0 for finance and 192.168.2.0 for sales. So our first test will be to see whether we can send traffic between terminals of two different departments. Yes, we can. The reason we can is because we have configured a router on a stick in the distribution layer, so the traffic is flowing through the first floor switch to the control switch. From the control switch is bridged on the router and it flows back to the appropriate VLAN. Now the question is, can we send traffic from any of these PCs to this remote network PC? It fails. Let's see why it fails. Try to send an IP address test, a ping test, pardon me. 192.168. The IP address configured on this PC is the 192.168.3.0.32, based around the 3.0 interface up here. I've configured the default gateway here, the 192.168.3.1 on this port down there. Show IP interface brief, and as you can see, the 3.1 is connected on Fast Ethernet 2.0. So let me get back to my ping test, that is 3.0. As you can see, the message we get is that the destination host is unreachable. Let's attempt again. Alright, the reason for that is because traffic flowing from this PC all the way to this router, but this router doesn't recognize the 3.0 network. If we repeat this process on the reverse direction, 192.168, ping command 192.168.1. Let's see, what is this PC IP address? Say that's 2.2. Alright, that is fine. 2.2. Destination host is unreachable. Again, the traffic flows from this terminal here to the router, but the router doesn't recognize these two networks. The way to configure the static routes between the two routers is very simple. You go on your router and you show IP route first. As you can see, the only two networks that are, we have three networks recognized at the moment, is the 1.0.2.0, the finance and the sales. They are based around the two sub interfaces. the ones on the router on the stick, okay, and the 40, which is directly connected via the serial 40 interface. So now what we want to do is go into the configuration terminal and instruct the router to see the 30 network. So we say IP route 192.168.3.0 with this subnet mask via serial /0 interface. So actually we instruct this router that every kind of traffic, any sort of traffic that is intended for this network, please put it straight into this physical interface. The other expression, if you wanted to use, is IP route 192, again target network 255.255.255.0, and the IP address that is your target. Actually, if that is 41, that is 42. Okay, this is the IP address where the traffic should be forwarded to. Okay, we don't need to do that right now. So if I do show IP route at the moment, you see that a new network is being added. It sees as it was directly connected via serial interface 40. The reason it sees it as a directly connected network is because serial interface 4.0 is physically attached on this router. So it assumes that everything beyond this point is actually part of this network as well. So I can end this, and we can go back to the ping test. Go to run and then try to run the ping test again. Of course, although we would expect for the message to now be able to get there, we have a new message, a request timeout message. As you can see, this before we had the destination host unreachable. This time we have a request timeout. Why is that happening? Because the traffic flows from this terminal into the switch, from the switch to that switch, and it gets to the router. This time though, router does recognize this network, so it forwards the traffic all the way here and it gets to the PC. This PC tries to acknowledge that I received your ping message, so it sends an echo message back. The echo message goes to the router, but the router doesn't recognize the two networks down here. As a result, the attempt to send the acknowledgement message back will fail, and as long as this PC will not receive an acknowledgement message, okay, it will assumes that the destination host it will not assume that the destination host is unreachable, but it will time out the request. In order to fix this problem, we need to configure static routes on this router on the core layer in order to be able to see the two networks down here. The procedure is identical to the one that I was shown before. So you go to the configuration terminal, you define the IP route to the networks we want, 168.1.0.255.255.255.0 to flow through the serial 00 interface. And I repeat exactly the same procedure for the 2.0 network. And if we show the IP route this time, you can see that the two new networks are added and they are recognized as statically configured networks. This time, if we attempt to send traffic, the traffic will go through. and it will go the reverse direction as well. Okay, so we can send traffic between the two different departments. You can send traffic between two different floors, and you can send traffic somewhere in a remote network away from your network by statically configuring the routes. The problem with static route configuration is that growing the network, the static routes will have to consider all possible networks and all possible routes. That can become a tricky task. For that reason, we have the dynamic routes, which we will see on very much later video. Thank you for watching.